Everyone, it's Mr. Rainsberg here. We're looking at lesson 1.2 part B, which focuses on histograms. Make sure you have your graphing calculator ready before continuing on the video. We'll look at how to input the data and create a histogram on those as well. We're also going to still look at interpreting and describing shapes when you're looking at the histograms and make a connection to the 1.2 part A information. Back in the 1.2 part A, you examined dot plots. And so right here is a dot plot. It looks at the number of math problems done each night by students, and you have the frequency. Now, when I look at this dot plot, I see just a lot of dots. There's a lot of values in this quantitative variable. So to analyze it a little bit better, it might help us to group them together. So what I'm going to do is I'm going to kind of draw these vertical lines and kind of separate these into groupings. So I have right here, I'll draw one right here as well. And notice I'm grouping them into intervals, classes, or bins of the same width on it. And what I'm going to do is I'm going to count how many are in each of those classes or in each of those bins for it. And so in the first one, if we just quickly do a quick count, that looks like we have about 30 here, and I'll write that. The next one, let's say just looks like we have about 54. This one, maybe we have about 45. Quick count there, carry the one, looks like 23, looks like 15. This one's a lot easier to count, looks like 3. So those are our counts. Now, if I wanted to, I could take this same information and I can generate, I would say, bars on it. And I'm going to kind of draw here is let's make this a size of 30, and I'll make this a size of 54. Here would be a size of 45. We could do boom, boom. Here is a size of 23. 23 should be a little bit lower based off of scaling, but it's not drawn to scale. My apologies. And then 15 we'll put about right here, and 3 we could put about right here. And so if we look at just the green, that's a histogram. And that allows me to gather a little bit more information when it comes to the shape, the center, the spread of that quantitative variable, the number of math problems done by students each night. Again, scaling on my histogram, I apologize, isn't quite there. I just wanted to show it as an introduction problem of what you're going to be doing. Keep in mind the bins, the classes are the same width on it. This one is from 0 problems to less than 5 problems. This one's from 5 problems to less than 10 problems, from 10 problems to less than 15, et cetera, et cetera, et cetera. And you of course, would have to finish labeling the graphs. Always label your axes. Don't be that student who does not label their axes on it. And that's where a histogram comes into play. We can gather more information when it comes to the shape, the center, the spread of what's going on here. Introduction problem, not in your notes. Let's go to the notes. And so that just kind of introduced this idea, this slide. Quantitative variables can take on many values. We saw that here, a lot of dots. By grouping them together, I may be able to see something a little bit clearer, and I can see my shape there. I can see really approximately where the center would be on it. So when you're looking at this, the most common graphic distribution of a quantitative variable is a histogram on it. And when I made a histogram, so there's your steps right there, is you want to divide the range of data into classes of equal width. And you heard me say classes. You also heard me say the word bins on this. You want to find out the count, and that's what I looked at, is the count, or you can look at the percent, the relative frequency of it in each of the classes. And always label and scale your axes. Of course, I did a poor job of scaling my axes in that brief histogram in the beginning, but always label and scale your axes for it. The height of the bar should equal the frequency or should equal the relative frequency, and adjacent bars should touch unless there is no data in that class. There's no individuals in that bin for it. So if we go back to this, let's just say that there were no students that did between 20 to less than 25 problems on it. In that case, the bins would not be all of them touching. There is a gap there, and there's a gap there because no one did that many problems for it. And so This example looks at how to make a histogram. It's on page 35 of your textbook. It gives a list of all 50 states and it tries to tell you the percent of residents from each state who were born outside of the United States. Now that is 50 pieces of information that we're looking at. That's a lot of numbers to put on a dot plot. And so what we're going to do is we're going to group them together. So this example is, how do you make a histogram? We don't have the table on your slides. We're just going to show you the classes, the bins, and show you the histogram for it. So since there are 50 pieces of information, just so you can kind of get the general idea of it, they broke that into different class sizes from 0 to 5, from 5 to 10%, 10 to 15%, 15 to 20%, 20 to 25%, and then 25 to 30%. So these classes represent the percent of residents from each state who were born outside of the United States. So right here, boom, percent of residents from each state who were born outside the United States. That is right there in your classes for it. And you can see it even labeled right here on the axes. And then it looks at the count. So they went through the table and it just counted, okay, how many were from 0 to less than 5%? On how there was 20. How many from 5 to less than 10%? Well, there was 13. And then you go through and you have the histogram created. Notice it's scaled, the axes are labeled. Now, when you're doing this, you want to usually have about 5 to 8 bars, 5 to 8 classes, depending on the size of the data set. So have about or at least 5 to 8 bars when you are creating a histogram for it. So histograms versus bar graphs. What's the difference? I mean, visually, there's one very simple one. We'll start with the middle one is in a histogram, the bars touch. For a bar graph, they do not touch. But the biggest difference between them is one of them is for quantitative and one of them is for categorical. Histograms look at quantitative data. The bar graphs look at categorical data. Now, if you think about the histogram, we look at the pictures of what we've been doing on it. The order does matter because the classes are based off of intervals 0 to less than 5, 5 to less than 10, 10 to less than 15, and so on and so on. But when you're dealing with a bar graph, they're categorical. The order you place the bars does not matter for it. So histograms are for quantitative, bar graphs are for categorical. That is probably the most crucial difference between them. And that's why we did the first lesson of what's the difference between categorical data and quantitative data. So bars in histograms represent equal width intervals, 0 to less than 5, 5 to less than 10. Bars in a bar graph represent frequency or relative frequency of each category. We already talked about touch and do not touch. On a histogram, you want to mark the horizontal axis with units of measurement for the variable. On bar graphs, you want to mark the horizontal axis with your categories on it. Another big difference, and it goes kind of with this first one right up here, the quantitative versus categorical, is bar graphs, you cannot tell me any information about shape. You can't tell me if it's skewed, you can't tell me if it's symmetric, because again, the order of the bars don't matter because they're categories. But when you're dealing with the histogram, you have the ability to tell me about shape. You can analyze center a little bit. You can analyze spread for it. You might be able to make, I guess, as a possible outliers that could exist. I mean, I could look at this right here and say, you know what, the percent of residents from each state of Ohio who were born outside of the United States, it's skewed right for it. What does that mean? That's where interpreting came in 1.2a. When you have this skewed right distribution of the percent of residents from each state who are born outside the United States, I mean, that could mean a majority of states have fewer than 10% of foreign residents on it. See that right here. If we look at where 10 is, you can see there's a lot of information over there. But we do have some of the states that have a larger amount of proportion of residents from each state who were born outside the United States. If we look at the center, I mean, if I think about it, there's 50 on there. So here's a count of 20. Here's a count of 13. That's 33. The middle of 50 is between 25, 26, the median of that. And so, right here, that bin is going to be where your center is, the 5 to less than 10. So from the graph, we see that the midpoint or the median would fall somewhere in the 5.0% to less than 10% on it. So that's where our of residents from each state who were born outside the United States. Context, always remember that. And so we have our shape, we have our center, we have our spread. Well, the spread can help us out here. Spread shows that we have the data ranging from less than 5% to a little over 25%. We would actually go to our table in the book in this case, and we'd be able to find the exact range to examine the spread. Now, if I want to talk about outliers, I don't see any possible outliers here. Now, if there were classes with gaps in between them, and all of a sudden, boom, a bar on the histogram over here, there's gaps, I would then say, you know what, that could be a possible outlier somewhere in there for it. But the histogram allows us to look at shape, center, and spread for the information as well. So this one deals with the NBA scoring averages. It is an alternate example in your book. It's in blue, so it's not in your notes on it. This lists off 30 NBA teams from the 2009-2010 regular season. Now what I did is I put these into Desmos for us. So I'm going to pull up the Desmos calculator online, and we can take a look at what's going on here. So as I pull up the calculator is I have right here the practice of statistics, fourth edition, alternate example, NBA scoring averages, they're there, and you see I'm starting to type in dot plot of A. Well, nothing popped up. That doesn't mean it's broken. That just means if you look at my scaling on my graph, it doesn't fit. I mean, 101.7, 99.2. So I'm going to kind of zoom out and I'm going to scroll over, and you might be able to notice there's the dot plot. And so I'm going to just go ahead and zoom in this area, and we can see the dot plot. Again, that's a lot of information for us. So maybe I'm going to want to zoom out and make sure I'm good. And maybe I'm going to want to create a histogram for it. So I'm just going to go right here and I'm going to type in histogram of A. Now to you, you're in the eyes, you're going to say, well, that's a bar graph, and it's not a bar graph because those bars are touching. That is still a histogram. The reason why these bars, it looks like a bar graph, is because my class width, you look right here, data set bin width, my bin width is 1. I'm going to make my bin width, we'll just go to 5. And so now, again, zoom out, you can see right here, there is my histogram. It has 1 here, it has 5 here, it has 16, 17 here, it has 5 here, 2 here. I can create a histogram on that as well. If I look at that shape, it is approximately symmetrical. It is mound shaped, bell shaped on it. The center looks like it's in the bin from 97.5 to a little bit less than 102.5 on it. For the spread, I can see the beginning and the end. I would really go to the table and look at and calculate what the range is from the table. And then the outliers, I don't really see any outliers. I don't see any bins without any values inside of them. And so that's really looking at this example across the board, and you kind of see it's already done for us. Boom, and here we go. This is a relative frequency. So we have our histogram that we looked at before. The one on Desmos was a little bit different than this one, which is fine. The bins were a little bit different. This was 90 to 94.9999, so the counts were a little bit different on it. But the main idea behind this I want to show you is that's frequency. This is relative frequency. So ready? Frequency graph for histogram, relative frequency for histogram. Frequency for histogram, relative frequency for histogram. Notice the shapes are approximately the same on them. So even when I'm using percent and I'm using counts, it doesn't change the shape of the histogram for us. And so right here we have different scale variations. We made the comment you want to have about 5 to 8 bins. And one of the reasons why is because look at the difference. Here I have 5 bins. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The scaling does change on it. I could see the center here. I can kind of estimate the center here, but you can see how it's not as smooth for us. So when you start to get too large, you might not be able to see the shape for us. So always try and go for at least 5 to 8 bins. So bottom line is make sure you use your histograms wisely. Do not confuse histograms and bar graphs. Histograms, quantitative variables. Bar graphs, categorical variables. Histograms, because they're quantitative, You can describe shape, center, spread, outliers, stocks. Bar graphs, they're categorical. The order doesn't matter. You can't. Don't use counts in a frequency table or percents in a relative frequency table as data. Use percents as set of counts on the vertical axis when you're comparing. So number 3 means this: if I have 2 sets of data and I want to compare them together, they may not have the same number of counts. They may not have the same sample size. So I'm going to make a comparison by using percents on them. So that's what number 3 says, is if you're trying to compare 2 sets of data together with different numbers of observations, different sample sizes, use percents. And just because a graph looks nice doesn't necessarily mean that there's meaningful data inside of it. So now what we have is the time to look at our calculator for it. So here is my graphing calculator. Again, I said make sure you have that ready. We're going to go through now. I'm looking at the 50 states example for it. I have all 50 states, and if you ever want to input information to your calculator, you're going to use this stat button right here. So let's highlight it in blue. So sorry, red. There is your stat button. Now what you're going to do is choose edit. So I'm going to hit enter. And right now you can see I have all 50 states, all the data inputted. That took some time. And I have all 50 states inputted, and we're going to have it in there. We're going to have our calculator create a histogram from it. So right there, you go to stat, edit, and you input your data. All set. So I'm going to hit second quit. And what I want to do is I want to realize them in statistics. And so if we're going to graph and plot things statistically, we're going to want to turn on stat plot. So I'm going to hit second. And right here in blue says stat plot, and so I'm going to hit y equals. So second y equals is stat plot. Right here, plot 1, I'm going to hit enter on that to turn it and select it. And I want to turn it on. I want to say, you know what? I want to graph statistical data that I have. So I'm going to go on there and turn it on. Now, if I hit the down arrow, we can see I have different options of the graphs, and we're going to be examining these all throughout the year, especially this box plot one on it. So this third one for me is your histogram. Now, right here, just to talk about this is your X list. This is the list of where your data is located, and we put it in L1. If I would have put it in L2, I would choose L2 on it. And so right here above 1, 2, and 3, 4, 5, and 6 in blue, you see L1, L2, L3, L4, and so on. So that's where you would choose it. So I'm all good. My list is set. It's all there. So I'm gonna hit second quit. And I want to show you something. Is if I go to y equals right now, notice up top there it says plot 1 and it's highlighted in black for it. That means you are ready to graph in statistics on it. But if I hit graph, it's right there, and that doesn't look as good. Now, the reason why that doesn't look good is because my calculator's still in, algebra 2, pre-calculus, calculus mode. I'm used to graphing functions. I need to tell my calculator, you know what? Statistics. And so I'm going to hit zoom, and I'm going to go to option 9, zoom stat. And so when you come in statistics and you're trying to graph from plot 1 or plot 2 or plot 3, zoom stat when you're graphing. And that's going to make your window size fit into there a lot better. It's like, hey, you know what? I need to zoom in like I'm graphing statistical data. So zoom 9 for zoom stat. And then if you hit the trace button, you will notice you can see the counts in each bin as I move to the right. And there's one with the gap. You can see right down here, your count is 0, my count is 1, count of 2, and so on and so on. So the trace button allows me to go in and count the number of frequencies that are in each class. So that is how you use your calculator for it. And by the way, your textbook right here, your textbook has in there directions on how to use your TI-84 as well to set these up. So again, we have stat, edit, input the data. Second, stat plot, you want to turn on plot 1, choose histogram, make sure your list matches. And then because you are in statistics, we hit zoom and option 9. But wait a minute, some of you might be having some fun this year and taking multiple math classes. Good job. Now what you want to do is you want to make sure you are ready for your other math classes. So right now you are going to leave, maybe you're going to go to calculus next, pre-calculus next, not good. So you're going to want to hit y equals. the quickest way to go back and forth between AP statistics and another math class is turning on and off plot one and fixing your graph. And it's not too hard. So I'm going to hit y equals, I'm going to hit the up arrow, and I'm going to hit enter. And that's going to deselect plot one. I'm no longer telling my calculator I want to graph statistical data. So that's off for us. But my window size is still set for statistics because we hit zoom stat. So I'm going to hit zoom 6. And right there, my window is perfect now for going to another math class besides AP Statistics. And when I come back into AP Statistics, I'm going to go to second y equals. I might turn on my plot again. And if I want to graph, I'm going to hit zoom 9. Up, I'm about to walk out the door and go to my calculus class. All right, I'm going to hit y equals. Let me turn off plot 1 and hit zoom 6. Done. So we looked at how we examined how to graph a histogram with our calculator, how to look at shape center spread as well for it. So if you have any questions, read your book, stop in, see Mr. Nichols or myself.